Hi guys, today we'll be talking about some calculus because I need to study for my test next week, and I would think that this is a great way of studying. I'd also like to say that these notes are not made by me, it's made by Corpus, so go check him out online, very helpful. So today we'll be talking about antiderivatives or integrals. So just so you're aware, not everything I say in this video will be correct because I am a student, I'm still learning. And so forgive me. But antiderivatives are basically the derivative of a derivative. Or in other words, if say f prime of x is x squared, so this will be the graph. Just imagine this is right. What is f of x? Okay, so f of x would be this, so x cubed over 3 or something like this. So basically before we had this graph, and then we had to ask you what is the derivative of it, which would be x squared. So we're just flipping things around. Alright, continuing on. So let's do example 1. So the antiderivative of that is, there's a trick that I learned. So for part A, you just take the constant out, and then this is x power 1, so 1 plus 2 is 2, and then sorry, I need to make some space here. 2 here, and then the flip reciprocal of 2 is 1 over 2. So your answer would be x squared. Okay, so find the general antiderivative, so just ignore all the signs. So x would be, take the x out, and then x squared over 2, which will be x squared over 2. Okay, this is a little bit more complicated. Again, take the constant out, and then plus 1, so 4 over 7 plus 7 over 7 is 11 over 7. Reciprocal of that is 7 over 11, or in other words 14 over 33, x 11 over 7. Similarly, this one you can rewrite it as x negative 2, x power of negative 2. You can take the constant out, constant out, and then plus 1, so x to the power of negative 1, and then negative 1, which is negative x negative 1. And then you can double check of any of these as well. So say this one will be so negative 1 times 1 is x, just x to the power of negative 2, which is same, so it's okay. Okay, lastly, the derivative of what is cosine. So you can just remember the derivative of sine x is cosine x. There it is, that easy. Okay, there's a list, you can look at it. Okay, let's go here. It looks pretty hard, but I'll just do it because it's not that hard. So firstly, I see that there are 3 different terms, so I'll just analyze one by one because nothing too crazy. So the antiderivative of 4 sine x is 4, and the antiderivative of sine x is negative cosine x, right? Because sine x is negative cosine x. Oh yeah, guys, I'm so sorry with the plus c. Wow, that's a big mistake. Stop, don't comment on it. Okay, so the reason why we plus c is that this can have any number that's falling behind it. So say f of x is equal to 2x, this is the graph. That's a terrible graph, right? So doesn't matter if it's 2x plus 1, 2x plus 2, or x squared plus 1, x squared plus 2, the derivative of it would be 2x. So x squared plus 1 plus 2, whatever, it's also equal to 2x. So the c is just a constant. And forgive me, I forgot about that until now. So anyways, as I was saying, sine x is negative cosine x plus c. I can't believe I forgot that, but alright, anyways, continuing on. So that's that. Next term, I'll use red. Here you can divide each term by x. So you can let's put better notation here. So the derivative of g prime of x is that, or in other words, let's rewrite the entire thing so that's easier for us to understand. So 4 minus 1 is 3. 1 half minus 1 is negative 1 half. 1 minus 1 is just 0, and then so that's 1, and then minus 7 cosecant squared x. You can't divide that x, and then plus whatever x. Okay, so that's our equation. So let's continue. So the red one, continuing on, pull the 2 out, x4 over 4 minus, or it can be like x4 over 2 minus, and then you get x, and then plus 1, which is 1/2, and then 2, negative 2, so it's plus. I really have to fact check that because I'm not sure if that's correct, but that looks right, right? Does that look right? That does not look right. Let's try again. Minus, so it's negative 2 x plus 2 over 2, so it's 1/2, plus x minus cosecant x 7, antiderivative of cosecant squared x, I believe it's let's see, what is negative cotangent x? Is it? No. Yes, no, maybe. Actually, I forgot all my derivatives. Yeah, I should be right. So negative cotangent x plus ln x. No, that's not right. That's the other way around. So this is x negative 1, so it's negative x. Is that right? Wait. 1 times negative 1 x 0. Okay, cool. What? So it's just negative 1? No, it's not. What are you talking about? R. 1 over x. Yeah, it's ln. It's ln. What am I doing? Knew that looked weird. Alright, and the reason why we put negative or absolute value of x is because you can't put a negative x, and that would just not work. Plus c, and then you can simplify it furthermore. Let's make sure we put this like that. Alright, that's your answer. Okay, next. So particular solutions are when you solve for c. Again, c is the constant. That can be anything, but it can also be a definite answer, and so we'll try to solve for that for now. And so differential equation for this, find the general, which is just plus c, and particular solution, which is plus a number. And so the general solution, let's just do that first, is, so the derivative of that is 3 times x4 x3 over 3. Did I do that wrong? No, I did right. Plus x. So that's just x cubed plus x plus c, and that's our first general solution. And then the particular solution would be solving for c. So we know that f of 2 is negative 3, so we know that f of 2 is equal to what was it, f2, so 8 plus 2 plus c, so c is equal to negative 7, so x cubed plus x minus 7, that was like alpha. So that's a particular solution. Okay, example 4, I think we get the gist of it. It's a bit more complicated, but I think it should be fine. Derivative, antiderivative of dy over dx is ex, so it's the same, plus 20, and then this we know is tan inverse of x. Okay, so plus c, so that's our first one. My boxes are a bit wonky, sorry about that, but same thing, plug it in. So e to the power of 0 will be 1. E to the power of 0 will be 1 plus 20 tan 0. Oh my goodness. Tan 0 would just be 1. 0 is 1, which is 0. Plus c, which means this is gone. That means c is equal to -3. Or in other words, dy over dx. Let's just not write that. E to the power of x plus 20 tan inverse of x plus, or not plus, minus 3. There it is. Okay.